In each of 11 through 16, suppose a sequence satisfies the given recurrence relation and initial conditions. Find an explicit formula for the sequence. R sub k equals 2 times r sub k minus 1 minus r sub k minus 2 for each integer k greater than or equal to 2, where r sub 0 equals 1 and r sub 1 equals 4. Now, to solve this, we actually have the solution given to us from the textbook. In the section, it says that given a second-order linear homogeneous recurrence relation with constant coefficients, which, by the way, is what we have right here. This is a second-order linear homogeneous recurrence relation with constant coefficients. And they even give us the format for what that means, which is exactly what we have here. The characteristic equation of the relation is t squared minus at minus b. So in this case, a is the constant coefficient attached to r sub k minus 1, which is 2, and b is the constant coefficient attached to the r sub k minus 2, which is negative 1. And so according to this, the characteristic equation would be t squared minus a, so minus 2t, and then minus b, which is plus 1, equals 0. So this is the characteristic equation. Then we can factor this, which is just t minus 1 squared equals 0. Now, the solution to this is t equals 1, but we have a multiplicity of 2. Now, according to Theorem 5.8.5, which is called the Single Root Theorem, if the characteristic equation has a single root, which it does here, a real root, then the explicit formula is this solution here. So the textbook actually gives us what the solution is. R here is the root, and the root that we got for the characteristic equation was just t equals 1. So we're going to plug in 1 into R of this solution. So our explicit formula would be R sub n equals c times 1 to the n plus d times n times 1 to the n. Now, raising 1 to any power is just going to be 1. So we get r sub n equals some constant c plus some constant coefficient d times n. Now we need to figure out what c and d are. And to do that, we can use the initial conditions here. We're told that if we plug in n equals 0, we should get 1 as the result here. So this means that 1 equals c plus d times 0. Which means that 1 equals c. That's an important part of our solution. And we're also told that if we plug in 1, we get 4. So that means 4 should be the result of plugging n equals 1. Now we already know what c is. C is just 1, so 4 equals 1 plus d, which means d equals 3. This means that the solution is r sub n equals 1 plus 3n. And that is the explicit formula for our sequence, and this works for every integer n greater than or equal to 0. Thanks, everyone, and I'll see you in the next video.